Hello everybody, welcome into another lesson, and welcome to the final lesson of the transformations unit and the final lesson of geometry altogether. After this lesson, we will be in Algebra 2 Trig. So congratulations on making it this far for those of you who have made it this far. And see how far you've come since the beginning of this course, and since you've stuck with me this long, for those of you who have been with me since the beginning, and even those of you who have joined recently, I thank you. And I look forward to the future working with you more in this endeavor to understand math better and to help you learn it better. So, today we are going to talk about dilations. Of course, you may know dilations like if you go to the eye doctor, you get your eyes dilated. That usually means your pupils are enlarged because they need to look in there for any nerve damage in your eyes or look at the various parts of your eye. Or, you can, another example of a dilation is at a movie theater. If up in their room where they project the movie onto the screen, it starts out as a very small image. Well, the image is dilated and cast onto the big screen at the movie theater. So those are good examples of dilations. Dilation notation, you have D sub O, meaning a dilation at the origin. So you have a dilation at the origin, that comma, then the K. That K is the multiple by which it's the scalar multiple by which you are dilating a point or a shape by. So that's what the K means. So it's a dilation through the origin at point O of K units. Now, if the absolute value of that K is less than 1, that scalar multiple is less than 1, the absolute value of it, you have what's called a contraction. So it shrinks it if it's less than 1. There's a reason I'm using absolute value for both of these, because you could have a negative scalar multiple, which would, if it's negative, indicates that not only is there either an expansion or a contraction, but there's also a reflection going on at the same time. Negative would indicate a reflection, and that it would actually be a reflection of the line y equals negative x, if that's the case. But then, of course, if the absolute value of k, your scalar multiple, is greater than 1, you have an expansion. So those are things to keep in mind. And I will set up our coordinate plane we're going to demonstrate here with some points. So we will demonstrate sorry about that. I'll definitely, when I start the next course here, get a different black marker. 1, 2. Just give me a minute to set up the coordinate plane here. I know normally I have this set up already, but I wanted to illustrate some points with the dilation notation. I want to have plenty of points because we're going to do some expansions, we're going to do some contractions. We're going to talk more about dilations and what they mean in terms of area and perimeter of shapes. Almost done here, folks. Just let me set this up real quick. Alright, I think that's sufficient. There, I got the coordinate plane drawn. So, for these exercises, we are going to plot some points here. There's going to be about 6 of them. It'll be about 6 exercises. So the point A occurs at 6, 0. So point A occurs at 6, 0. Point B occurs at 4, 2. And then point C occurs at 2, negative 2. Alright, so we have our 3 points. We're going to do some dilations with each of these points here. So, the first one, we're going to have a dilation about the origin. Let me make this a little bit bigger. A dilation about the origin, and this time your scalar multiple is 2 of the point A. So we have a dilation through the origin at point A with a scalar multiple of 2. So what does that entail? That means that I'm going to take my coordinates for A, which would be 6, 0, and I'm going to multiply by that scalar factor of 2. So I'll take 2 times my 6, 0 coordinate, which would simply give me 12, 0. So the coordinate for my A prime would be at the point 12, 0. So I'll go ahead and plot that. So A prime would be at 12, 0 by the given dilation. It's a lot like vector scalar multiplication, pretty much the same idea. Alright, now let's do this with B. This time we'll do it with point B. So we are going to, of course, dilate through the origin at point B with a scalar multiple of 2. So take your coordinates of B, which would be 4, 2, and multiply that by the scalar multiple of 2. 2 times 4 is 8, 2 times 2 is 4. So B prime would put you at the point 8, 4. So B prime would put you at the point 8, 4, would put you all the way over here. And then, of course, let's do this through point C. So this time I'm going to dilate through the origin at point C with a scalar multiple of 2 by a scale factor of 2. So take your coordinates for C and multiply that by 2. So take 2 times your coordinates for C, which was 2, negative 2. Well, that would end up giving you 4, negative 4. So 4, negative 4 would be found right there. So C prime is at the point 4, negative 4. So dilation or contraction, you just take your scalar multiple or your scale factor. It's also, you can call that your scale factor, and then you get the coordinates of your transformation, depending upon whether it's an expansion or a contraction. In this case, it would be an expansion because the scale factor, the absolute value of that, was greater than 1. Alright, let's do few more exercises with that, but let's not erase our original points. We're going to stick with the same points actually for A, B, and C. The original A, B, and C, the preimages. It's going to make our lives a lot easier here. So let's do that. Let's reconnect here at 12 on the x-axis. Alright. Now this time, So we're going to dilate through the origin with a scalar multiple or a scale factor of 3 at point A. So let's do this with a scale factor of 3 through the origin at point A. So go ahead, take your coordinates for A, which would be 6, 0, multiply it by 3. So take 3 times 6, 0. Well, that would give you the coordinates 18, 0 for your A prime. So A prime would be 18, 0. So let's find 18, 0. Right here. So A prime can be found at the coordinate 18, 0 with the given dilation scale factor of 3. Now let's go ahead, let's do the same thing to point B. So at point B, well, you still have a scale factor of 3. Take your coordinates for B, multiply it by that scale factor of 3. So 3 times 4, 2. Well, that's going to give you a coordinate of 12, 6. So your B prime will be located at 12, 6. 12. So there's your B prime located at the point 12, 6. And then, of course, let's go ahead and do the same for C. So this time we're going to dilate through the origin at point C with a scale factor of 3. So if we do that, then take that scale factor of 3 times your coordinates for C, which would be 2, negative 2. Well, that's going to give you your C prime being at 6, negative 6. So C prime can be found, of course, at the coordinate of 6, negative 6. All right, do about 4 more of these. Keep up our original points, but get rid of the images. All right, so this time we have, good one. We are going to dilate through the origin with a scale factor of 1/2 at point A. So, to find our A prime, we need to dilate through the origin at point A by a scale factor of 1/2. So let's go ahead then, take that scale factor of 1/2, multiply by your coordinates of A, which would be 6, 0. Well, that would of course give you 3, 0. So your A prime would actually be located at 3, 0. So let's go ahead and plot that here. There's your A prime at 3, 0. Let's do the same for B. So if we dilate through the origin at point B by a scale factor of 1/2, just take that scale factor of 1/2, multiply it by coordinates of B, which are 4, 2. Well, that's of course going to give you the coordinate of B prime being at 2, 1. So B prime would be located right here at 2, 1. Notice it seems like they're all in close proximity to each other. And then let's do the same for point C. Let's dilate through the origin at point C by a scale factor of 1/2. So if I do that, I'll just take half, that, which is that scale factor, times the coordinates for C, which are 2, negative 2. Well, that would give me C prime located at 1, negative 1. So C prime you will find at the coordinate 1, negative 1. And there's your C prime. So you see how much closer together they are instead of scattered. So that was clearly a contraction instead of an expansion. That one was a contraction because half is definitely less than 1. Alright, what's the next one here? Problem 4. Oh, another good one. Now, what if I dilate through the origin by a scale factor of negative 1/2 at point A? So I have a scale factor of negative 1/2 this time. Well, like before, I'm going to take my scale factor. This time that would be negative 1/2. Multiply that by my coordinates of A, which would be 6, 0, which actually would give me negative 3, 0. So A prime would actually be located at negative 3, 0. So not only do I have a contraction, I have a reflection also in the line y equals negative x. Now, what if I do it to the point B? So let's go ahead and do that through point B, through O at point B. Again, take my scale factor of negative 1/2, multiply that by my coordinates for B, which are 4, 2. Well, that would end up giving me, of course, negative 2, negative 1 for my B prime. So I would be right here for my B prime, all in close proximity to each other. Now let's do this at point C. So if I dilate through the origin by a scale factor of negative 1/2 at point C, just take that negative 1/2 times my coordinates of C, which would be 2, negative 2. Well, that would give me negative 1, positive 1. So C prime would be located at negative 1, 1, right here. So not only do I have a contraction, since the scale factor, the absolute value of the scale factor is less than 1, I have a reflection in the line y equals negative x. Alright. We're starting with simple points. We're going to get to triangles in just a minute. We're going to do this with some whole triangles, but I just wanted you to see with points in general. I have, let's see, 2 more of these. Okay, so we have a dilation through the origin with a scale factor of negative 2 at point A. Well, right away, the absolute value of negative 2 is greater than 1, so it's going to be an expansion. But that negative sign indicates we're going to have a reflection also. So to find the coordinate of A prime, I'll take that scale factor of negative 2 times the coordinates of A, which would be 6, 0. Well, that's going to give me, of course, negative 12, 0 for my coordinates of A prime. I'll be at negative 12, 0. 12. Here we go. A prime is located at the coordinate negative 12, 0. Okay. So let's do the same at point B. This time we'll dilate through the origin with a scale factor of negative 2 at the point B. So take that scale factor of negative 2, multiply it by your coordinates for B, which would be 4, 2. You end up getting the coordinates negative 8, negative 4. So 11, 10, 9, 8. Not the best drawn coordinate plane, but that's about where B prime is at negative 8, negative 4. And then likewise, let's do it with point C. So, of course, take your scale factor of negative 2, multiply it by your coordinates for C, which are 2, negative 2. Well, that would end up giving you negative 4, positive 4. So C prime would be at the point negative 4, positive 4 right here. So we not only have an expansion, we have a reflection in the line y equals negative x. And you can see if you drew y equals negative x through here, they would perfectly reflect each other. One more. I'm only doing this next one to illustrate a point. Okay, this is going to be a good one. What if I had... Actually, let's do two more. I have a reason for it. So, we are dilating through the origin with a scale factor of 1 at point A. Well, okay, we don't actually have to do too much. If the scale factor is 1, you're just going to take 1, multiply it by your coordinates. Well, 1 times anything is itself, right? That means that A is also A prime, then, since you end up back with itself. You would do the same for B. You would end up getting B prime is also at B, and then likewise C prime is also at C if you just had a scale factor of 1. Because we didn't talk about if the scale factor equals exactly 1. If it's exactly 1, if the absolute value of it's exactly 1, then it doesn't change size. It's an isometry. So as you can imagine, dilations then are not isometries because they do change the size of a line or an area or a perimeter, what have you. Now let's say I just tack a negative 1 on that scale factor. So what if I tacked a negative 1? Well, the size still wouldn't change, but it would change my coordinates. Basically, that's indicating a reflection. So if I negate my coordinates for A, negate 6, 0, I of course would end up at the coordinate negative 6, 0 for my A prime. 4, 5, 6. So A prime would rest at negative 6, 0. And then of course I'll do the same at B. So if I have a scale factor of negative 1, just negate the coordinates of 4, 2. Well, that's going to put me at negative 4, negative 2 for my B prime. So negative 4, negative 2 rests right there. So B prime is at negative 4, negative 2. And then let's find C prime, which would be, we'll just take those coordinates, multiply them by negative 1. So negative of your C coordinates would be the negative of 2, negative 2. which would put you at -2, +2. So -2, +2 is located right here. So that's your C prime at -2, +2. And as you can see, the size didn't change at all because the scale factor, the absolute value of it, is equal to 1. But we just reflected in the line y equals -x. Alright, where are we at now? Alright. I'm going to keep the coordinate plane up so I don't have to draw it again, just to make our lives easier. And actually these next few exercises will be slightly easier. At least in my opinion they will be. There we go. Now here's some problems for you. I'm going to do 6 more. So let's say you start out at the coordinate 2, 0, and you go to 8, 0, right? We need to find the scale factor. So if 0 to 0 is 0, right? But if I go from 2 to 8, well, that's a scale factor of 4, right? The scale factor is 4. Because 2 times 4 is 8, 0 times 4 is 0. And now, would this be an expansion or a contraction? Well, the absolute value of 4 is greater than 1. This would be an expansion. So this actually would be an expansion because the absolute value is greater than 1. Alright, so what if we had the coordinate 2, 3 to 4, 6. So the dilation of the point 2, 3 yields to point 4, 6. What is your scale factor? Well, 2 times 2 is 4, 3 times 2 is 6. So it looks to me that your scale factor, abbreviated K, would be 2. You have a scale factor of 2. Take each your x and y coordinate, multiply them by 2, you'll get 4, 6. And is this an expansion or a contraction? Well, the absolute value of K is greater than 1, so this is also an expansion. Not as much as the last one, but it's still an expansion nonetheless. Alright. Got 6 more problems with these. And then we're going to do like 4 problems with triangles. And then we'll be done. Okay, now we start at the point 3, 9, which is dilated to give us the point 1, 3. So the dilation at point 3, 9 yields the point 1, 3. What would be our scale factor in this case? Well, if you look at this, looks like if you divide by 3, 3 divided by 3 is 1, 9 divided by 3 is 3. Which means you multiplied everything by 1/3, right? Because when you divide, you multiply by the reciprocal. So it looks to be that your scale factor in this case is 1/3. So 3 times a third is 1, 9 times a third is 3. So yes, you would get a scale factor of 1/3. Now, the absolute value of K is less than 1. What is it this time? This is a contraction. It's contracting. So this one would be a contraction. All right, I have about 3 more. what if we went from the point 410? So we start at 410. We are then, it tells us that the dilation yields to the point -2, -5. So the dilation of 410 yields to -2, -5. What is our scale factor? What would that be? Well, if you take 4 times -½ you get -2. If you take 10 times -½ you get -5. So your scale factor is -1/2. Now, the absolute value of -1/2 is what? +1/2, which is less than 1, so this is a contraction. It's a contraction, and it's also important to note that whenever you have a negative scale factor for a dilation, it's a reflection. You have a reflection in y equals -x. So a negative dilation is a reflection in the line y equals -x. About 2 more of these, then we'll do 4 triangles, then we'll be done. All right. What if we had, good one. We start at the point 0.1/6. The dilation yields to 0.2/3. Okay. So we go from 0.1/6 to 0.2/3. What is the scale factor? Well, 1/6 times what equals 2/3? If we want to know what the scale factor is, take 1/6 times k, set that equal to 2/3, which would give you k would equal 4. So you actually have a scale factor of 4. And then since the absolute value of k is greater than 1, this is an expansion. This would actually be considered an expansion, since the scale factor is 4. I got just one more problem. And then we got 4 more after that, then we're done. Alright, so we start with the point -6, +2. We end up with the point +18, -6. So we start at the point -6, +2. The dilation results in +18, -6. Well, what is the scale factor? Well, -6 times -3 would equal +18, right? 2 times -3 would equal -6. So it appears that your scale factor is -3. So that's our scale factor. Now, what if, so what is this? This would be an expansion because the absolute value of -3 is greater than 1. It's definitely an expansion. And since it's a negative scale factor, that means it is a reflection in the line y equals -x. So you got a reflection in the line y equals -x, since you have a negative for your scale factor. Alright, so now we got 4 last exercises where we're going to demonstrate on some triangles. Alright, so I'm going to plot some points here for the triangles. Point P will be located at -1, +1. So there's point P at -1, 1. In fact, let's list that. P is at -1, 1. Q is at 0, -1. Here's Q. Q is at 0, -1. And then R is at 4, 0. So I'm going to go ahead and make myself a nice little triangle here. And then R can be found at the point 4, 0. So there's my triangle PQR with the given coordinates. P at -1, 1, Q at 0, -1, R at 4, 0. Now, we are being asked to... We are going to dilate through the origin with a scale factor of 3 at each of these 4 triangle PQR. You can also dilate the whole triangle, which means you're just going to take each of the points individually and do it. So what does that look like? That's going to look like the dilation through the origin with a scalar multiple of 3 at point P. You'll take 3 times the coordinates of P, which would be -1, 1, which would end up, of course, giving you -3, 3. So you'll get your P prime at -3, +3. So there's my P prime at -3, +3. In fact, why don't I list that over here? So P prime would be at -3, +3. Now let's find Q prime. So I'll just take 3 times the coordinates of Q, which was 0, -1, which would give me the coordinate of 0, -3. So my Q prime will be located at 0, -3. So there's my Q prime at 0, -3. In fact, I'll go ahead and start connecting these points. And then, of course, I need to find R prime. So take 3 times my coordinates for R, which were 4, 0. Well, that would put me at 12, 0. So now let me plot 12, 0. 12. There's my R prime at 12, 0. So we can clearly see that triangle P prime, Q prime, R prime, since it has a scale factor of 3 from PQR, is definitely an expansion, right? So we can say that triangle P prime, Q prime, R prime is an expansion because the scale factor is 3, which the absolute value of that is greater than 1. So this here goes to show you that any dilation is not an isometry because it changes the size. But there is another question being asked. There's a couple of other things. Well, what is the ratio of the areas and the ratio of the perimeters? So, if 2 shapes have scale factors, what does that mean? That means that they are similar shapes. So a dilation will map one triangle to a similar triangle. So they will be similar but they will not be congruent. So that means each side has, so the ratio of P to Q, PQ to P prime Q prime would be 1 to 3 for each of these, right? Since you have a scale factor of 3. So the ratio of perimeters right? If, of course, PQR, that's always your 1. That's what you started with, right? So if P prime, Q prime, R prime is 3 times more than PQR, then that tells you that the ratio of the original to the dilation is 1 to 3. Which also would mean the ratio of perimeters is in fact 1 to 3. So then what's the ratio of the areas? What is the ratio of the areas? Well, if the perimeter would be the same as the scale factor between the two, that means you just take your scale factor or your ratio of perimeters, because they're both the same, and you square them, right? For similar shapes, you just square the scale factor, which would give you 1/9. So the ratio of areas from triangle PQR to triangle P prime Q prime R prime is 1 to 9. And I got 3 more exercises like this. Yeah, I know I'm butchering this, but it's necessary. All right. Okay. 3 more. Let's see. What are the coordinates of the original triangle? All right, so we're going all the way to 5, 6, 7, 8, 9, 10, 11, 12. All right, so the coordinate of point P is at 12, 0. P is all the way at 12, 0. Here's your coordinate P. All right. Now, you have Q. Wow. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Q is all the way at 0, 15. So here's Q. Q has the ordered pair 0, 15. So let's go ahead and connect P and Q. So what is R? Let's find out what R is. R is located at negative 9, 6. 6, 7, 8, 9. Right there. Just trying to find it. Okay. Let's just connect these bad boys now. So there's my triangle PQR, with R having the point negative 9, 6. I'm a little off, aren't I? I should probably come down some. No wonder it looks so skewed. Here's R. My bad, folks. I was going up 9 instead, and I don't know why I was doing that. I'm not sure why I did that, but I did. Okay. There we go. That's more like it. So let's see what they give us for dilation this time. They give us that the dilation through the origin, through the center of the origin, is a scale factor of 2/3 for triangle PQR. So we are going to dilate triangle PQR by a scale factor of 2/3. So that means we take every coordinate and we multiply it by that scale factor of 2/3. So take 2/3 times your coordinate for P, which was 12, 0. Well, what is 2/3 of 12? So that's going to be 8. That would put you at 8, 0. So you end up having the coordinate then 8, 0 for 4, 5, 6, 7, 8. Here's 8, 0. That's my P prime. Now let's find 2/3 of coordinate Q. 2/3 of coordinate Q would be times 0, 15. 2/3 of 0, of course, is 0, but 2/3 of 15 would be 10. So my Q prime would end up being at the point 0, 10. So there's Q prime at the point 0, 10. Let's go ahead and connect these. Let's find R prime, which would be 2/3 times the coordinate of R. So 2/3 times negative 9, 6. So that'd be negative. So that would put me, let's see, at negative 6, 4. So my R prime would be located at negative 6, 4. Let's go ahead and find that. There's my R prime. And clearly we can see that since the scale factor given to us to multiply to get the second triangle, the absolute value being 2/3 is less than 1, that means that triangle P prime, Q prime, R prime is a contraction from the original. Right? So now we have to find the scale factor of one triangle to the other in general. Well, here's a trick. Yes, you did the dilation to get your second triangle, to get P prime, Q prime, R prime. Now we have to find the ratio of perimeters and ratio of areas from the original to the transformation. Basically, you're just going to invert it. All you're going to do is invert the scale factor that you multiplied by to get the transformation. So the scale factor of the triangle PQR to triangle P prime Q prime R prime would actually be in the ratio of 3 to 2, since you have to invert you just take the reciprocal of the scale factor you multiplied it by, you would get the scale factor of 3 to 2, meaning the ratio of perimeters is also 3 to 2, since that's the same as your scale factors. So the ratio of perimeters would also equal 3 to 2. Which means then the ratio of your areas, take that scale factor, set it to the second power. So take that take that 3/2, raise it to the second power. Well, you would end up getting 9 to 4. So the ratio of areas between your original triangle and the transformed one would be 9 to 4. Alright, 2 more problems, then we're done. So yes, clearly these dilations are not isometries. Alright, 2 more, then we're done. We just reattach the coordinate plane together. Alright, I think that's everything reattached. So, what do we got this time? The point P is at 3, 0. So point P is at 3, 0. Let's find point Q. Point Q is at 3, 4. So here's my point Q at 3, 4. Then let's just deal with R. R is going to be at 6, 6. So R has the point 6, 6. So let's go ahead and make our triangles. So there's triangle PQR. Now, what we have to do is figure out the dilation of this triangle with a scale factor of -2. So we need to dilate triangle PQR with a scale factor of -2. Well, okay, a couple things. That negative sign tells you not only is it a dilation, it's a reflection in the line y equals -x. So, we're going to have a reflection, and then that scale factor of -2, you take the absolute value of it, you get 2, which is greater than 1, means you also have an expansion. So we have a reflection and an expansion occurring. So now let's just take -2 times each of your coordinates. Coordinate of P is 3, 0, which would give you -6, 0 for your coordinate for P prime. So P prime is at -6, 0 right here. There's P prime. Let's find the coordinate of Q prime. So again, take that scale factor of -2 times your coordinate of q being 3, 4. Well, that would put you at -6, -8 for your q prime. So now let's find -6, -8. Should be about right there. So there's my q prime. So let's go ahead and connect those. And then let's find, of course, r prime. So we will take -2 times our r coordinate of 6, 6, which would put me at -12, -12. So let's find -12, -12. 12 will be right here. Go down about here. Now there's my r prime at -12, -12. And what do you know? I have not only an expansion, I have a reflection in the line y equals -x. If you picture a line y equals -x, you would see the reflection in that from the first quadrant to the fourth quadrant. So I have negated both of my x and y terms and switched them around, essentially. So that's a reflection in the line y equals -x. So for sure, we can definitely argue that triangle P prime, Q prime, R prime is definitely an expansion. So now the question is, what is the ratio or the scale factor of triangle PQR to triangle P prime, Q prime, R prime? Well, basically you're just going to take your scale factor and invert and multiply, but when you find the scale factor of one shape to another, you don't consider the negative sign that you did the original dilation with. So pretend that negative isn't there for the two. To find you would just take the reciprocal of 2. You would get a ratio of 1 to 2 for triangle PQR to triangle P prime, Q prime, R prime. It would be in the ratio of 1 to 2. Which would mean then that the ratio of perimeters, so the ratio of perimeters would be the same as the scale factor for the two shapes, which would also be 1 to 2. So then what's the ratio of the areas? You just take your scale factor and square it, you would end up getting the ratio of areas being 1 to 4. So the ratio of areas of these two shapes is 1 to 4. The ratio of their perimeters is 1 to 2. And I got one more exercise, then we're done completely with this lesson. Oh, man. All right. I think that does that. Let's see here. All right. So we have P at -2, -2. So here's P, which is located at the point -2, -2. Q is located at 0, 0. So there's Q. which would be at the origin at 0, 0, and point R, well, let's go ahead and connect these dots. Point R would be located at 4, 0. Is that right? Yeah, point R is at 4, 0. So let's go ahead then and connect these dots, and you have a small little triangle. Now, we got, of course, triangle PQR, P at -2, -2, Q at the origin at 0, 0, and then R is at 4, 0. This is where it gets fun. They give us that they want us to do a dilation through the origin at each of these points with a scale factor of -1/2 for triangle PQR to get triangle P prime Q prime R prime. So first look at the negative sign, which means we definitely have a reflection. Next, look at the scale factor itself. The absolute value of -1/2 is 1/2, which is less than 1, which means you actually have a contraction. So let's go ahead and find the coordinates of P prime, Q prime, and R prime. So take that scale factor of -1/2 times then the coordinates of P, which would be -2, -2. Well, P prime would be located at 1, 1. So we just located P prime at 1, 1. There's our P prime at 1, 1. Now let's find Q prime. Well, I think it's safe to say anything times 0 is 0, so Q prime would also be at 0, 0. So here's your Q and Q prime are one and the same at 0, 0, but we do need to find R prime. Let's find R prime, so take that -1/2 times 4, 0. That's going to give you, of course, the coordinate -2, 0 for R prime. So let's go to -2, 0. There's your R prime at -2, 0. And that's a very itty-bitty little triangle, isn't it? But it definitely still reflects in the line y equals -x. So we can for sure say that triangle P prime, Q prime, R prime is a contraction from the previous triangle, right? Now we need to find the scale factor, the ratio of the original triangle PQR to the triangle P prime, Q prime, R prime. Well, if your scale factor that you multiplied to do the dilation by was -1/2, that means you're just going to omit the negative sign and then take the reciprocal of 1/2. Well, it would be 2 to 1. So the scale factor then from triangle PQR to triangle P prime, Q prime, R prime has the ratio of 2 to 1. Which means what then? That the ratio of perimeters would also be what? 2 to 1. The ratio of perimeters is 2 to 1. Which, since your scale factor was 2 to 1, what does that mean for your areas? Well, the ratio of areas, you just take that 2 to 1 and square it. You would get a ratio of areas being 4 to 1. If you square 2 to 1, you get 4 to 1 for your ratio of areas. And in general, dilations, again, they are not isometries because the size and area does change. So that's why they're not isometries. But it does map one similar shape to another similar shape. So you have similarity rather than congruence. And we can use the previous theorems of properties of similar shapes and apply those here. So folks, that's it for the lesson. That's it for geometry. The very next lesson we will be in Algebra 2 trig. So stay tuned for the Welcome to Algebra 2 video. I hope everyone has a great night. Take care.